Hey, what's going on, everybody? It's Mike here from AXC Garage. Welcome back to our channel. You guys haven't subscribed to the channel, make sure you go down there and click the subscribe button right now. Due to popular demand, we have another engine teardown videos for you today. Let's take a look. All right, John, so what do we have today?
So what we have is the heart from a 4th gen TL. This is not just the motor from one, but this is out of a all-wheel drive. The all-wheel drive is a 3.7 liter single overhead cam VTEC. And that's on the all-wheel drive models. The 2-wheel drive models came with the 3.5 liter. This is also the same motor that's in the MDX and in the ZDX. So they're all pretty similar. It's a different cylinder bore. I'm sure there's other differences with cam lobes and compression, but for right now, it's 3.7 liter. This one had some knocking coming from the engine, and with it being a high mileage car, it was a lot cheaper instead of repairing it to go ahead and source a used motor with a decent amount of miles, nothing too out of hand, similar to what the car came in with. And we swapped the motor out so that we didn't have to do any machine work or any work on the bottom end. So I guess tonight what we're gonna do is we're gonna break it down, all the way down, and take a look and see where the failure is. All right, so when you start breaking down the J-Series motor, the first thing you're gonna have to do is go ahead and remove the intake manifold. That covers half the bolts on the, valve covers. So we'll start first with taking off the throttle body. This throttle body is one of the largest stock drive-by-wire throttle bodies that we have. It's the 3.7 liter. You can see things fairly large. The neat thing about the throttle body on all these drive-by-wire cars is they eliminate the need for an idle air control valve, and it will fluctuate throttle angle to adjust for idle surging, motor mount adjustments, everything like that. It all comes right here. So we're gonna start by taking off the throttle body, then we're gonna start taking off the intake manifold. All right, so when we pull off this upper plenum cover, we can see that we have a flapper valve located in here. And what that's gonna do, it's gonna allow for a different torque curve by changing the flow of the runners here. This is the actuator on it, and it just opens this valve and changes the flow of this. It changes low end torque. Also, what we have here is the EGR port. This is where it distributes the EGR gases into this chamber here, which then recirculates the exhaust gases back into the intake manifold.
And down over here, we have the EGR itself right down here.
Yeah, when this opens up, there's a passage that flows from your exhaust manifold, and this also grabs the exhaust from after the catalytic converter, and then pipe plumbs it back through this manifold up into here. All right, so once the upper plenum is off, we have our lower intake plenum and our fuel rails and injectors that you can see here. This is the EGR port that feeds from the EGR valve. These are lower intake runners. These feed straight into the head, and you can see here, these are our injectors. This has port injection, so that means it injects into the intake port, not directly into the cylinder like they do on the direct injection motors. This is less efficient, but it still works pretty good. So next thing we're gonna do is work on taking the valve covers off. Then we'll start taking off our coolant manifold here and our timing covers on this side. So we just drained the coolant and we're just draining out the last bit of oil in the motor so that hopefully it doesn't make too much more of a mess once we get this going. When we break it down even more, try and keep the oil in the pan and the coolant in the can. See how that goes. All right, so we have it broke down pretty good before we start taking the major components off of it. Here we take a second, take a look at what's going on inside the head. So this is a SHOC, or single overhead cam. It's also a VTEC motor. So that being said, the setup is a little different from the K series that we saw previously, and it's even more different than the B series motor. This here, these are our lost motion assemblies. These are our rockers. This is the exhaust rockers. And the VTEC lobe is located on this. These are our pins that lock together right here to engage VTEC. It has one cam with a bunch of different lobes on it, and that's located deep down inside. You can't really see that. To get to that, we'll have to take this rocker assembly off, which we will do. Now over here, we have our timing belt side. This is pretty interesting because it's pretty standard across the whole board with all of our V6 timing belt engines. And the, I would say, what's this, the J series. So what we have here is our our water pump. This is our timing belt. This is our bank 2 cam. This is our bank 1 cam gear. This is our hydraulic tensioner, our idler pulley that is adjustable by this tensioner. This is the non-adjustable idler pulley. This is our crank gear. This is our oil filter housing and our VTEC assembly with the VTEC oil pressure switch. right, so we're gonna go ahead and open this up so you can see the cam underneath. So I think we found a problem. If you want to take a look right here on our cam, this is a good cam lobe right here. This is what we have. Doesn't look very good at all. And also here, we can see the cam has deteriorated as well in a few different locations, and also over here on bank 1 as well. Ooh. Yeah, that thing's completely failed. This is our VTEC lobe. The higher lobe is the VTEC lobe. This is a primary lobe. That's going to be making a ton of noise and losing lift on that in particular valve. Now, that may not give you low compression, but it's not going to give you proper opening. That's a major problem. That's going to require new rockers in the head and also a new cam. That may not be the only problem. What caused this problem? Oil starvation, defect of the cam. Let's dig deeper and see. It works. So here we got the cams out. So your cam is internally lubricated and through these ports right here. Oil comes in through it, so the cam's a little bit messy. You'll have oil dripping out of it for that reason. These cams are completely destroyed. Like I said, I'm not sure if that's the problem, but it's definitely a result of a problem. So let's keep digging deeper and see what else we find. So as you can see right here, there's a lot of heavy carbon deposits on this piston. What that's showing me is these motors are a little notorious that if you don't use the proper octane gas and you get on the car pretty hard on a cold start, you get heavy carbon deposits on here, which eventually will clog up your oil scraping ring and cause a bit of blow by and oil burning. Now, all that can be prevented with using the proper recommended gas octane on these cars and allowing the car to at least start to warm up before you go out and beat the crap out of it. As you can see, a whole lot of carbon. So we have our oil pickup and our windage tray off. Now we're going to go ahead and remove the oil pump. And then after that, we're going to work on getting the connecting rods out. Right here is a seal. This is the seal that usually leaks when your oil pump leaks. Very cheap seal, very difficult to get to. The oil pump is a machine fit, so in order to seal that, there's no gasket other than the one that I showed you. There's just a light coat of Honda Bond goes right here around the edge. All right, so next up we have the connecting rods. We're going to pull the connecting rod caps off, push the pistons out, and then we'll go ahead and take the crank out. All right, so rods are out, pistons are out. Now all we have to do is remove our main caps to get the crank out. So we have our two bolts here, and we also have a bolt on either side that stabilizes the main caps. So we're gonna pull these side ones first, then our top ones, then crank right on out of there. All right, so there's a lot more parts to this than I thought there was once you lay it all out. But now that we got it all laid out, I really thought this car had a bottom end noise. But it turns out that all of our bearings on our connecting rods, everything looked good. The culprit turned out to be the head. The heads failed on this car. Did they fail for lack of oil? I don't know, I don't think so, because usually our bearings are the first part to go. Something having to do with the rockers or the cam composition was our fault at this. The repair for this would probably be 2 new heads, and then put them on and you'd send this car on the way. Still, once again, best cost effectiveness for the customer was a junkyard motor. Another thing we realized when we had the pistons out is that this was already had the oil ring, which is the bottom here, saturated with carbon. If you can see it, all the carbon stuck inside there. You shouldn't be able to see in there like that. This car was going to have a potential for excessive oil consumption. Once again, best solution for the customer was a new motor. Seeing the J37 motor all broke down, it looks a little bit complicated, but this is it. A very good performing motor and very cheap to get used. That's why you see a lot of people swapping this motor into other cars. And for the most part, it performs great in 90% of our cars. This is just a small issue we've seen, and we don't really know the maintenance history on this car. But that's about it for now.
All right, guys, there you have it. We got this J37 engine completely taken apart, and find out the problem was coming from a cylinder head camshaft. If you guys like what you see, make sure you hit the subscribe button and turn on that notification, and drop a comment below and let us know how we are doing. My name is Mike, behalf of AXC Garage. Thank you so much for watching. We'll see you guys on the next one.